All right. So I know that I said that we finished 1.6, but let's do just another one of these just so you could see them. I did want you to see these. So look at 24. So I'll do 24. And if you want to try, mm, 23 is going to be a little different. But if you want to try 23, feel free to. All right. So we have f of x. We have our f of x, and we have our g of x. Now here it says we want f of g of x. F of g of x. All right, so that's what it looks like. So remember, we start out with the plans of f of x. So f of x is x squared minus 9. Now I'm going to take out that x. So wherever you see an x, take it out and then replace it with what your g of x is. So here, I'm going to put it in parentheses. You don't need to, but I will. I'm going to replace that with x plus 3. And dun. Remember, squares and squaring and square rooting are inverses of each other. So here these cancel each other out. Dun. And we're left with x plus 3 minus 9, which is just x minus 6. That's it. All right. Now, I didn't do any others ahead of time, but yeah, we could try some others as well. Um, I'll show you one with like 26 because that one is it is a little special in that we're gonna end up with something illegal. Dun dun dun. So again, we want f of g of x. All right, so start off with the plans of f of x. So you have negative 4 over x. Now I'm gonna take out that x and I'm gonna replace it with my g of x. And then you might be thinking to yourself, oh, we're done. There's nothing we can do there. But no, remember we can't have a radical in the denominator. So what we're going to do is we need to simplify this rational expression. So we're going to multiply the top and the bottom by that same radical. That way we can cancel it out because it's like squaring it basically. But we can't just multiply the bottom. We also have to multiply the top to keep it equal. And then when you do that, you end up with, on the top, we have negative 4 times the square root of x plus 8. And on the denominator, we have x plus 8. And that's it. And if you're wondering where the x plus 8 come from, remember square root of x times square root of x plus 8 times square root of x plus 8. That's like the square root of x plus 8 squared. So these cancel each other out, and you're left with x plus 8. That's it. All right, hold on. All right, and there we go. That's it. All right, yeah, so if you want to try 25, you can as well. That's a good one. Similar to this one. Yeah, yeah, that's good. If you want to look at any of the others, just let me know, and we'll do it. And no, no, we'll do it in class. Unless you want to just ask me, and I'll send you answers there. Where are the notes? There we go. Okay, was that it for this section? I also have 37 in my notes. Oh, okay. Yeah, these are pretty cool. Um, you might see one or you might see one of these in a placement test, but not too often. You're more likely to see the ones that we just saw, the compositions. But sometimes you do see these where it says find the two functions f and g such that h of x equals f of g of x. Neither function may be the identity. So you can't use f of x equals x. You can't use that. Why? Because it would be too easy. You'd say like for number, no, we're going to do 37. So yeah, if you say f of x equals x, then all you have to say is g of x equals 8 over x minus 5 squared. That's cheating because it's basically the same thing. All right. So that's why you can't use identity. All right. So the way you want to do this, and yeah, if you want to try 30, go ahead. The way you want to do this is you want to try to find out the big picture. Okay. So look at the big thing and then focus in. Okay. So find the big thing first. So overall, is this, the 8 divided by x minus 5 squared. And then you want to focus in on the x. So that the expression that has the x, that's going to be our g of x. Okay, so here, da-da-da-dun, I'm going to block this part out. So if I block this part out here, okay, because that's our g of x, and I replace it with an x, there's our f of x. So our f of x is 8 over x squared. Now there's other ways to do this. I'll show you another one. Okay. And then our g of x is the one that we blocked out. What did we block out? Ta-da! X minus 5. And that's the easiest way, in my opinion, to do that. Whoa, highlighter. Cool. All right. So g of x is x minus 5. Yeah, and that's it. Our answers. Now, another way to do this is to not just have x minus 5 as gx, but x minus 5 squared as g of x. And that one's okay also. In that case, it would be f of x would be 8 over x, and then g of x would be x minus 5 squared. Okay, either one works. So, all right. Yeah, so try 30. 30 is a good one to try. Um, I'll do one that's similar, I guess. 32. So 32. Okay. So again, focus in on the whole function. All right. And then focus in So look at the whole function first. That's going to be your f of x. Okay, but let's replace so now we're going to focus in on the expression that has the x. Right there. That's going to be our g of x. So 4x plus 8. And if you block that out and replace it with an x there, there you go. That's your f of x. We have absolute value of x minus 9. Ta-da! That's it. All right. Hopefully that helps. Uh-oh. And I'll leave it at that. If there are any others that you want to look at, just let me know. Um, oh, there are some that have two x's. Um, Maybe I should do one that has two x's. And that's okay. All right. So I'll leave it at that. And if there are any others that you want to go over, just let me know. 23, 25, 30. Hmm. Do I want to show this one? I guess we can. All right. So remember, there are two different types of word problems that you can have. They're going to be the super easy ones where they give you an expression, they give you a formula, and they give you an equation, and all you have to do is plug in the values into that equation. All right. However, there are some like this, which are the harder ones, where they don't give you an equation or anything, but they do give us a picture. So here we have a picture, and it looks like we have a right triangle. Hey, that's right. All right. So we have our right triangle there. Oops. So whenever you have a right triangle, you want to think of Pythagorean theorem. Okay, so here it says an airplane flying above a landing strip at 275 miles per hour passes a control tower zero point 0.5 miles below at time t is equals 0 hours. All right. So find the distance d between the airplane and the control tower as a function of the horizontal distance from the control tower h from the control tower to the plane. All right. So we got our right triangle there. Oh, yeah, let's do blue. Why not? So you have a right triangle. Whenever you have a right triangle, Pythagorean theorem, a squared plus b squared equals c squared. Cha-cha-cha. All right. So a squared plus b squared equals c squared. Um, and you're basically solving for D. So you could just plug in the values here. So A, what do you want to let A be? H? Let's let A be H. Let's let B be 0.5. And let's let C be D. Okay. D has to be C because C is the hypotenuse. Yeah, so D is the hypotenuse, which is C. So that's the one D has to be. Okay. All right, so we want to solve for D. So yeah, opposite of squaring is square rooting. We just take the square root of both sides and get square root of h squared plus 0.5 squared. And let's do that. We know 0.5 squared is 0.25. And there we go. Oh, as a function of the horizontal distance h from the control tower to the plane. Yeah, there you go. That's all we had to do. We're finished. It's a function of h. Yeah, there you go. So that's A. And then B, it says find h as a function of time. Find h as a function of time. So that means we want h of t. Okay. And here, so distance equals the speed times the time. All right, the speed is 275 miles per hour, and then our time is t. And there you go, 275 t. I should have used different colors, I'm sorry. And C, find d of h. So d of h, all right, so start off with d. Start off with d, we have h squared plus 0.25, and then erase the h. Erase it with 275t. Then 275 squared is going to give us 75,625. I did that in my head. No, I'm just kidding, I didn't. I have it on my notes. And t squared plus 0.25. And what does this represent? This represents the distance of the plane from the control tower as a function of time. Oh, tower as a function of time. That's it. All right. And then the last one, it says if the plane continued to fly the same distance from the ground how far would the plane be from the control tower after 10 minutes? So the way we do that is you'd think you'd just plug in 10 for t, right? But no, because this one is in minutes and t is in hours. So what we have to do first is we have to convert 10 minutes to hours. Now, if you want to use this one, I really like this. You'll see this a lot when you get to physics, okay, and chemistry. This one, as long as you just focus on those units, it'll help a lot. So how are minutes and hours related? 60 minutes are in 1 hour. And we want to convert it to hours. So that's why we want hours to be on top. Okay, and when you do that, look at this. Our minutes cancel out. So here we have 10 divided by 60 times 1, but it doesn't matter. So 10 divided by 60 is going to give us 1/6 of an hour. All right, I'm just going to leave it as a fraction there. So we have d of, um, so this is basically d of t right here, this thing there. Okay, so d of 1/6 is going to be square root of 75,625 times 1/6 t, 1/6 squared plus 0.25. Use a calculator, and you end up with 45.8 miles. That's the distance. And that's it. Mm, I think I'll leave the inverses for tomorrow. So yeah, that's gonna be it for today. Um, yeah, I'll leave the inverses for tomorrow. Okay.